Good morning, students.
Morning, sir.
Good morning, sir.
Morning. We have done question number 5 the last time, right? This is a pretty easy one. This exercise, as it progresses, it becomes a little more difficult. So, since this is my fourth class today, cannot speak very loud also. So here, let's see question number 6. It says a circus tent. Okay, you know what a circus tent look like, right? Circus tent look like this, right? But in a bigger way. Circus tent, it will look like this. Okay, let's see what the question says. So the circus tent is in the shape of a cylinder. So the circus tent has a cylinder. Let's draw the cylinder first. And let it be irregular, okay? No issue here. So it is in the form of a cylinder of diameter 24 meter. Remember, we don't have any use for diameter. Okay, whatever you see as diameter, don't forget to convert it into radius. So it's given here, the diameter is how much? Diameter is 24 meter. Height is small actually, right? So height is 4 meter. And this is surmounted. Okay, surmounted means there is a top portion here. On top of this cylinder, there is another portion. Surmounted by a cone of the same radius. So on top of this, we have a cone also. So the cone and the cylinder, they have the same radius, right? They share a common radius. And the cone has how much? The cone is same radius, but the height is 5. So this height is how much? This height is 5 meter. Question wants find the capacity of the tent. Okay, when it comes to mensuration, whenever you see capacity, you should always know that it deals with the volume. Volume and capacity, they are used interchangeably. Volume is equal to capacity. Okay, whenever the question asks you to find out the capacity, it means you are asked to find out the volume. The question wants the capacity of the tent. That means volume of the tents. Combine these two figures together. And the cost of the canvas, right? So this radius is how much? 24 meter. Question 1, the cost of the canvas, and the canvas is at the rate of 120 per square meter. So the tent must be made of canvas, right? It is made of canvas. Cost of canvas is how much? 120 per square meter. So for 1 square meter, the cost is 120 rupees. How to find out the cost of the canvas is, you just have to find out the area of the canvas first. That means the area of this portion, the portion where the canvas is supposed to cover. So curved surface area here, curved surface area here. You add them together, you will get a total curved surface area. That much curved surface area you have to multiply by 120. Let's discuss as the question progresses. Okay. So first of all, we need the capacity of the tent first. That means the volume of the tent. So volume, since the figure consists of 2 portions, one portion is the cone, one portion is the cylinder. So if I add the volume of cone plus volume of cylinder, we will get the volume of the whole tent, right? So that's our strategy. You find the volume of the cone, you find the volume of the cylinder, you add them together. So let's write down what is given for which figure first. So for the cylinder, how much is the radius? Radius is 24 meter. How much is the height? Height is 5 meter. We don't need anything else. Okay. We need the radius and the height. We don't need anything else. And coming to the conical part for the cone. Radius is the same, right? It will be 24 meter. Sorry, height should be 4. Height of the cylinder should be 4. I made a mistake. So for the conical part, the radius will be the same as this one. Radius will be the same as this one, right? But the height is slightly different. Who has turned on the microphone? Turn it off. Unless you don't have a question. And the height is 5 meter. Okay, in order not to confuse which is the height of which, let's make the height of the cylinder h1. Height of the conical part is h2. So cylindrical part I'm writing h1, conical part I'm writing h2. Now find the volume of the tent. This will be, we will add volume of cylinder plus volume of conical part. Volume of cylinder is how much? You know the formula, right? Pi r square h1. I'm not writing the radius as r1 or r2 because the radius between the cylinder and the cone are the same. So no need to differentiate 1, 2 here. We will just write r. That's enough. And volume of the conical part, what's the formula? 1 by 3 pi r square h2. Different height, right? That's why I'm writing the h2. h2 is from the conical part. Now, whatever can be taken out as common factor, I told you all to take out common factor first and then put in the value later on. So, pi r square, we can take out common factor. Pi r square is here and here also. That means h1 will be remaining in this first term, right? Second term, we will have 1 by 3 remaining, h2 remaining. Okay, keep it there. h1 remaining from the first one. 1 by 3 h2 from the second. Okay, time to put in the value now. 22 by 7. R1, R is 24 into 24. H1 is how much? H1 is 4 plus 1 by 3 into 5. Okay, whatever cancellation, we don't see any cancellation here, right? 7 and 24, we cannot cancel them. So the only thing that can happen here is you multiply this first and then add together. So what we are going to have? We are going to have 22 by 7. 24 into 24 into, let's check this out. Let's find out how much is this on the side. Okay, 4 plus 1 by 3 into 5. Look here. So we will have 4 plus 1 by 3 into 5 will be 5 by 3. And if you multiply 3 4s will be 12. 12 plus 5 will be how much? 7. 12 plus 5 will be 17. So we have 17 by 3. So now 17 by 3 here. Cancel out now. 3 8s are 24. So what is left? 22, 24, 8, 17, 7. Now you can multiply and divide. Multiply the numerator, the whole thing. You have to multiply 22, 24, 8 and, sorry, 8 and 7 and then, sorry, should be 17. Divided by 7. So this is a huge volume actually. We will have 10,258.28. If I made any mistake, you check it out, okay? I think I
Sir,
don't know.
how is the radius 24?
It's given. Okay. I made a mistake from the beginning, right?
Yes.
Okay then. Yeah, you have to change it. This is diameter. So radius will be 24 divided by 2. The screen is, that means I have to make a correction here also. So this should be 12 into 12. 12 into 12. Let's stop the downward portion. This is wrong. But 3 4s are 12. We have 22, 12, 4, 17 by 7. Yeah, let's check out again. Let me check out again through calculator. If we do the calculation, it will be very long. So 22, 12, 4, 17 divided by 7. This will be 2564.57. We are finding out the all the units given here are in meters, so we will have meter cube here. Unit will be in meter cube. Okay, screen is something wrong with the screen. We will have meter cube here. Okay, you copy up to here. We will find out the capacity portion is done, and we will come to course of the canvas later. Any mistake, check it out. Okay, the multiplication and division, even I make mistakes. So you have to rub this out. This is not 24. This is 12. All right, then I'm rubbing this off. The bottom portion, I'm rubbing it off. So for this portion right here, for this portion, find the capacity part is done. Course of the canvas. For the course of the canvas, what we need to know is we need to know the surface area. How much surface area is it required for the canvas? Okay, so our goal is to first find the surface area first, and then the course part we will come to it later on. So cylindrical part, in order to find out the surface area, we don't need anything else more than this R and H. But when we come to the conical part, right, for the conical part, we need three things actually. We need R is, okay, this is not 24, this is supposed to be 12. Okay, you change it, okay, R is 12. Conical part R is 12 meter. The height is 5 meter. And we need one more thing. We need the slant height also. We need this portion right here, this part right here. We need this part right here. So we need to find it out. Slant height is represented by L, and the formula will be R square plus H2 square. Put in the value now. R is 12 square, H2 is 5 square. So we will have 12 square is 144, 5 square is 25, 169, which is 30. So for the cylindrical part, we have the radius and height. For the conical part, radius and height was already given. We have already utilized it in finding out the capacity. But we need one more parameter, and that is the slant height. So slant height formula is this. And I have shown you all how the value of L come into being. Consider this. This is the L. This is the H2. This is the R. Screen is little wet. So H2 here and the R here. If you look here, this is a right angle triangle. So we can use Pythagoras theorem here, right? Hypotenuse square is equal to height square plus radius square. And if I find out the L, the square will go to the other side and it will become root over. That's how this formula come into being. And we put in the value as given, and we find out that length height is 30. Now find out the surface area. Curved surface area, actually I'm writing CSA of the 10. So we will use curved surface area of cylinder. And curved surface area of cone. So curved surface area of cylinder, what is the formula? It's 2 pi RH. What about the curved surface area of the cone? Pi RL. And you know that there is an H here. This H should be H1, the height of the cylinder, not that of the cone part. Okay, don't try to confuse there. H1. Now, whatever can be common factor, take it out. Pi R is common factor from both. So take it out. We have pi R inside bracket. What do we have? 2 and H remaining and L remaining. Time to put in the value. So we have got 22 by 7 into the radius is 12. 2 into H1 is how much? H1 is 4. Right. Then L is how much? 13. Okay, you copy up to here. We will continue the calculation further. Okay, you have to understand that 11 square is 121. So 12 square is 144. 13 square is 169. 14 square is 196. 15 square is 225. So the square of numbers from 11 to 15, try to remember them. Okay, rubbing it off. So if we continue further, let's see, we will have 22 by 7 into 12 into, yeah, we have got 2 4s are 8, 8 plus 13 is 21. Cancel it, 7 3s are 21. So we are left with 22 into 12 3s are is 36. 72, 72, so we have got 792 centimeters square. So this much meter square, we will need to make the tent. We will need 792 meters square. What's the cost of square meter? 1 meter square, how much is the cost? 120 rupees as is given here. If it comes to 20 meters square, we will have to multiply 120 and 20, right? But what is the total canvas that we will require? We will require this much canvas in order to make the tent. So what you have to do is cost of the canvas, you have to multiply this much which is needed and the cost per square meter which is 120. So you can continue here, cost of canvas. So 792 into 120 rupees. How come I'm writing 729? Okay, you multiplied 792 and 120. Easier to use calculator on my side. So the cost is 95,040 rupees. Okay, copy up to here. Anything that you don't understand, you can say it right now. These are either 4 mark or 5 mark questions. The 2-part ones actually. So it will take some time to teach also. One question is taken 30 minutes. Okay, copy this. Then we will move on to the next question. Moving on. My voice is very loud. So here, next one. It's similar. Okay, it's similar actually. Circus 10 of height 15 meter is in the form of cylinder of diameter 32 meter and height 3 meter. Surmounted by a cone of the same radius. Find the volume of the tent and cost of the canvas. You try to do it. Okay, same question here, except what is given here is, let me show you. I'm just going to give it as a hint. I'm not going to calculate this. You all try to do this as homework. What is given here is a circus tent of height 15 meter. The circus tent is, the total height is 15 meter. And it consists of a cylinder of diameter 32. This cylindrical part, the diameter is how much? The diameter is 32 meter. Height is 3 meter for the cylindrical part. Okay, so this part right here. So this part right here is 3 meter. That means the remaining will be how much? Out of the 15, if 3 is gone, we will have 12, right? So this part right here, it will be 12 meter. The 12 meter will be that of the conical portion, isn't it? So for the conical portion, the diameter will also be 32. Cut it down, you divide it by 2. 32 divided by 2, it will be 16. So the radius is 16, height is 12. And for the cylinder, height is 3, the radius will be same, it will be 16. So using this, you find out the volume of the tent. Use the previous type of question. You just need to change the value of the H1, H2, and R. And the cost of the canvas, it's similar, so you try to do it. Let's make this as home assignment. Okay. Question number 7. Okay, next question. So this next question, question number 9, is asked very frequently in your board exams. So it says it's a typically 4-mark question. Okay. So it says here, a geyser, water boiler. You know a geyser, right? What's in the bathroom? looks like this. There will be a coil inside. When water flows through it, the coil, when the electricity is turned on, water will flow through it, and then the water will get heated, and you get hot water in the morning for bathing. So a geyser is in the form of a cylinder with hemispherical ends. You try to draw the figure first. So here is a, so this is your geyser. So on top there is a hemispherical ends. Okay, so hemispherical ends on top and bottom. If the length of the cylinder is 56 centimeter, length of this cylinder, this portion right here is 56 centimeter. Diameter of each end is 18. The diameter is, this part is 18. This part is also 18. Right then, let's do. This portion right here is 56. The diameter right here is 18. We want to find the capacity of the geyser in liters. Capacity means volume, right? You have to find out the volume, but the volume we usually write centimeter cube or meter cube. So instead of writing meter cube, we want this in liters. Okay, let's find out the volume first, and then we will convert that into liter. Okay, I will teach you how to do it in liters later on. But for the time being, let's just find out the volume of the geyser. So here you can say for the hemispherical part, how much is the radius? Radius will be 18 divided by 2, which will be 9 centimeter. Remember, the 18 is given as diameter. Okay. And how much is the, come to the cylindrical part? For the cylindrical part, radius is 9 centimeter. Height is 56 centimeter. Find out the volume. Volume of geyser. So you have to add the volume of hemisphere, and volume of cylinder. Volume of hemisphere plus volume of hemisphere plus volume of cylinder. Volume of hemisphere is how much? We know that it's 2 by 3 pi r cube, right? The other hemisphere, it will also be the same. Volume of cylinder is how much? Pi r square. 2 by 3 and 2 by 3, we get 4 by 3 pi r cube. Take out common factor. We can take out pi, r square and r cube. We can take out r square common factor. So what is left then? 4 by 3 r plus h. Remember, 4 by 3 is left if pi r square is taken. And out of the r cube, if r square is taken away, out of r cube, if r square is taken away, we have r left. Now time to put in the value. Okay, 22 by 7. R is how much? R is 9. And 4 by 3 into 9, plus height is how much? 56. Okay, we will do cancellation. Let's do cancellation here. 3 and 9. 3 3s and 9. Others, we cannot do any cancellation further, right? So we will keep it, and then let's see if we can do further cancellation if after addition of these two, and then let's see if we can see any common factors. Okay, so you copy up to here. We will convert the volume into liters later on. Copy up to here. Okay, let's rub it off to here. Okay, now if you continue from there, we will have 22 by 7 into 9 into 9. Into this bracketed portion, how much is it? 4 3s is 12. 12 and 56, how much is it? 68, right? So 68, it cannot be cancelled by 7. Nearest factor is, nearest multiple is 63, so it doesn't fit. So the only thing we can do further is we have to multiply all the numbers. So 22 into 9 into 9 into 68 divided by 7. Now whatever is given here is in terms of centimeter, right? So when you find out the volume that you are going to get, that's going to be in centimeters. So this value is 121,176 divided by 7. So the final value is 17,310.85 centimeter cube. Okay, but the question doesn't want to find the volume in terms of centimeter cube. It wants in liters, right? It says here in liters. Find the capacity of the geyser in liters. So if we want to convert it into liter, the standard equivalency is 1 meter cube is 1000 liter. Okay, 1 meter cube means we are multiplying 1 meter 3 times. If I convert this into centimeter, then 1 meter will be 100 centimeter. 1 meter will be 100 centimeter. The 1 meter will be 100 centimeter. So multiply all the 100, 100, 100, we will have 1 followed by 6 zeros. What? 1 followed by 6 zeros, right? So 2 zeros from each 100. This centimeter cube is equal to 1000 liter. And if I convert this, 1 centimeter cube will be this part, this portion, it will come to the other side. And we are going to have 1000 divided by 1 followed by 3 zeros. If you cancel the 3 zeros above, 3 zeros below, what we are going to have is 1 centimeter cube is equal to 1 by 1000 liter. So 1 centimeter cube is 1 by 1000 liter. 2 centimeter cube will be 2 into 1 by 1000, right? So 100 centimeter cube will be 100 into 1 by 1000, isn't it? So yeah, if I want to convert this centimeter cube into liters, what you have to do is you have to multiply this by 1 by 1000. It will be converted into liter. Yeah, 1 centimeter cube is 1 by 1000 liter, right? So according to this, if you use unitary method for this 17,000, you have to multiply it. Okay, the best we can do here is, since there is a 30 in the denominator, we can divide these to 17,310.85 by 1000. So what you are going to do is the decimal point is here. The decimal point is right here. If it is divided by 1000, then because of the 3 zeros, it will move 3 places. 1, 2, 3. It will move 3 places and the point will be here. The decimal point will be right here. This part, right? So we will have 17.31 liters. You don't need to write this 85 and everything else because just 2 decimal points is enough. Okay, you have to understand where the point comes here. Why the point comes here? Because of the 3 zeros, you are moving the decimal 3 places. Okay, copy this and you have to keep this portion. Let me rub off the figure. You have to keep this portion as note on the side. This portion is important. You have to keep this as note on the side. Okay. Keep this on the side as note. If it was in meter cube, okay, if there was 2 meter cube, what we have to do is we have to multiply 2 and 1000 because 1 meter cube is 1000 liter. But if it is given in centimeter cube, you have to multiply with 1 by 1000. 1 by 1000. Same as dividing by 1000, okay? Okay, copy this, keep this as note on the side.